Okay, let's move on to question number 6. All right, so the next question is covering system of equations, and it reads, how do you solve negative 2x plus y equal 1 and negative 4x plus y equals negative 1? So basically, they're asking for the values of x and y, which will satisfy both of these equations, okay? And if you look more closely, you would understand that these both are line equations. So if we were to think about this graphically, they're actually looking for the point of intersection between these two lines. And the point of intersection is going to be the x and y that will solve both of these equations. Okay, that'll make both of these equations true, basically. And they ask us to use substitution, so we're going to use substitution. All right, so the first thing that I want to do is I'm going to write down our original equations again. So negative 2x plus y equal 1. And the other equation is negative 4x plus y equals negative 1. Okay, so for the first rule of using substitution is that you need to isolate one of your variables for either equation, okay? So I'm going to use our first equation here. I'm going to isolate for y. So I'm going to manipulate it in a way that I move all the x's to one side. So I move the negative 2x to the right side by adding 2x to both sides. So I get this. All right, and I'm going to label this 1. Okay, so now I'm going to say sub 1 into 2. So I'm claiming to take this new equation and sub it into this. So any y will be subbed by 1 plus 2x. So what do I get? Negative 4x plus 1 plus 2x equals negative 1. Okay, and if I simplify this all together, we get negative 2x equals negative 2, and then we get x equals 1. So now we have found our value of x, which will make these two equations be true. However, we still need our y, so I'm going to label this 3, and we're going to sub 3 into 1 to solve for y. Okay, so if I sub 3 into 1, we get y equals 1 plus 2, which equals 3. Okay, so now we have found our point of intersection. Therefore, 1 and 3 is the solution to our system of equations. Okay. All right. So in general, there could be multiple points of intersection, but in this case, we have 2 lines, right? And the 2 lines will always have only one point of intersection. They'll only have one solution that will make both of these equations true. But when you move up to quadratics, or like if you're calculating a system equation between a quadratic function and a line function, you might have 2 points of intersection, right? So you have to be wary. So whenever you're evaluating this, please look at the nature of the functions first, so that you can kind of understand how many points of intersection you have. Okay? So yeah, I'm going to move on. So this solution is correct. Cool. All right.